So in this video, I actually want to talk about what is the difference between a theory and In this video, I want to talk about what is the difference between a theory and a hypothesis, and talk to you in terms of how I intuitively think about what is the difference between a theory and a hypothesis. So if you don't know me, I'm Professor Dave Maslach. I'm an Associate Professor of Innovation Strategy and Entrepreneurship. And I created this whole reciprocity project to give back as much as I possibly can. There's so many people that help me out that I wanted to pay the favor forward to help you out. So I created this sharing economy editing platform. Please do go check it out. I really would appreciate it if you would go and get some credits. It would help out with the project tremendously because we can get this thing off the ground and it'd be very, very beneficial. Oh, here comes Izzy. Izzy, come here. She's come over. Yeah, my doggy Izzy. Here she is. Okay. And I thank you. Okay. And what then after that, I started doing these YouTube videos. She's attacking me. YouTube videos. Hi. YouTube videos to get the word out about the Reciprocity Project. And actually, this video was inspired by Tessa Pertowski Christensen. And thank you so much for making this suggestion. Okay, you can go. And thank you so much for making this suggestion. It was a really cool idea in terms of understanding what is the difference between theory and a hypothesis. So, and if you don't know, Tessa, unfortunately, if I call you out on a video and I help you out, or again, call you out and answer a question, you have to go out and do something nice for somebody today. It doesn't matter who it's for, just go out and do something nice and let us know how that goes in the comments below, because I think that would be really, really fun, because the name of the game is reciprocity. Just go out and do something nice for somebody and have no expectations in return. So, all right. What is the difference between a theory and a hypothesis? I'm going to sort of intuitively talk about this. So we often think, a lot of people think that science is a bunch of hullabaloo, right? We hear about that all the time. But what we forget is sort of the progression of how science actually evolved over the years, that it actually came out of sort of religious beliefs or how we viewed the world around us. And we started to formalize and think about some of these ideas a little bit more. Scientists are really just everyday people. Long time ago, back in the day, they were just everyday people that actually just started thinking about things. They were either, religious folks of some sort, generally, somebody that's affiliated with the Roman Catholic Church back in the day. But, that has changed dramatically. Just because that was the dominant religion in Europe at the time. But now, there's lots of people. And then, back in the day, there was also kind of people just kind of hacking things, right? It's not science how we understand it today. It was sort of the industrial production nature of science, how we understand it today. Science was very much a citizen sort of view of the world. And so they started developing, and people started developing these ideas of what is, theory versus proposition versus hypothesis and all these kind of fancy words. And really, a theory is just your framework and how you understand the world. And we can sort of flip around different theories and how we understand the world. And each context generally has its own theory. And we have these ideas of how things actually work. And so somebody might be viewing something and then they might have this aha moment where they say, oh, this is really cool. I view the world in this sort of way. And so what people do is they write down in a very rigorous fashion, how they view the world and what are the implications, what are the assumptions that come about of this particular theory. Now, normally, we've come a long way since then in terms of what that looks like. If you read some of the older stuff, it's like really hard to read and really muddied and stuff, but they had really great ideas. But now we're a lot more precise in terms of how we're understanding what theory is and whatnot. And we normally with a lot of theories, we don't do a lot of sort of big grand theorizing so much anymore. There's still part of it in terms of, these big grand ideas, but most science is sort of boiled down into sort of simpler things where each individual paper is sort of a piece of a puzzle. And what we're looking at with this is we're looking at sort of, what is the relationship between something that happens, a thing, and looking at how that relationship is associated with B, some other thing. And we're looking at, whether A goes up, this thing goes up, does it affect B in some sort of way? Does B go up or does it not go up, or something along those lines? And we try to really take a deep dive and try to have an explanation of why those might coexist together, why one thing might go up and the other one might go down. We try to come up with arguments based on what we already know and what people have already showed before. And that's why it's kind of, similar to law in a lot of different ways in what we're trying to do, because they look at, we look at what arguments or what other people said and trying to look to see how it sort of fits together. And then what ends up happening is, inevitably another scientist, another professor, another researcher is going to say, you did not think about this. And then we have to write in there and say, we did think about this, but, this doesn't hold because X, Y, and Z, right? And so that's how a theory gets developed or something gets really rigorously understood. And now sometimes it gets a little bit more complicated in terms of having more of a grander theory where they start having more and more things together. But really what we're looking at is something and how the world works. And it's usually inspired from everyday life, from what we see around us, or some sort of phenomenon. Sometimes it gets a little bit more, deeper down, because what ends up happening is that as you work in a field, say you work in chemistry, your everyday life becomes chemistry, right? So then you start taking, just talking about chemistry or chemical bonds, that's not interesting anymore because you've done it for so long. So then you start taking a deeper dive and start talking about, I took chemical engineering in my undergrad, but it was so long ago that I forget a lot of stuff. So then you might start talking about, well, what is the nature of this specific kind of bond? And then that becomes really interesting for you and you start talking about it. And, it just so happens that there's very few people that understand that. So that's why it becomes a little idiosyncratic at that moment, or a little unusual or, obtuse, I guess, as people start investigating those things. But I'm petting Izzy right here. She's right here. So what we end up doing then is testing this theory using different hypotheses, right? So we have this sort of grand thing, or, somewhat grand thing, and how we think the world actually works between A and B. And then we say, how do we empirically test this? What can we actually derive? What's an insight that we could drive in the real world? Now, remember, a lot of stuff is actually inspired from the real world. So after we sort of came up with, we do, it's called inductive reasoning, where we look at the world around us and draw conclusions from that. So once we draw those conclusions, often what people will do is they'll go out and try to test it in different ways. So we say, the ground hurts when I walk on it. Why is that? The ground works that when I walk on it, or my feet hurt when I walk on the ground. Well, it's probably because of gravity, but that's a theory. We don't really understand that completely, right? And why all that kind of stuff works. There's still gaps and holes and stuff, and that might be overchanged, and in 500 years, something better that comes up, but that's the whole nature of what we're doing. But we go about and we say, if we have gravity, if there is gravity, not only should an apple fall from the tree, but because of gravity and my mass, there's going to be points on my body that are going to be under more pressure than other points, and there probably is going to be a moment where your feet are going to hurt from that. So then we might sort of derive some sort of hypothesis, which is a testable proposition, where we say that maybe we can test this and say, in different states of gravity, under different conditions of gravity, people are going to have sorer feet. Their feet are going to they're going to be more painful under different conditions. So we might say, let's send somebody up to the moon and see if their feet hurt, and compare it to the people that are on Earth, and if they hurt less, we have a large enough population, or we sort of do some sort of calculation, and we compare what is going on between people on the moon versus people on Earth, and we say there should be theoretically less people on the moon that have sore feet. And then we go and we calculate that and look at that, and we just simply say, oh yeah, this theory holds. Once we find that, we say that there's a chance that this theory holds. We're not always kind of really couching things. That's the thing that scientists do, is they always couch things because we're never really quite sure. So what we're trying to do is actually refute. We do a lot of work in trying to throw out a specific theory. That's the job. That's actually how science works, is we are very skeptical. And so we always try to throw out what the current theory is. We might say, well, it's gravity that's causing it, right? It's causing problems. Well, then we want to test the fact that, that there is something else that's actually causing those problems and not gravity. And if we can't rule out all those something else, whatever that thing is, and we say, yeah, it's a chance, we have a pretty good insight that's probably gravity that's causing pain on our feet, right? So you can see that, and the reason why we sort of couch in that way, we really never quite know if there is something that is truly there, and it's just because the world, the nature around us, we never quite know. Humans can never quite know something, so we do everything we possibly can to refute, to what's called falsify, to throw out what we know, or what we can sort of possibly say with this. And so that's what hypotheses actually do, is they try to not support a theory. That's not what we're trying to do. We're actually trying to prove that theory, quote unquote, prove that theory is wrong. Never really can prove anything, but what we're trying to do is just throw it out and say, yeah, that theory doesn't work. Let's move on to something else, and what that can explain it a little bit more. Now, the reason why we do that, it's not only that the world is really hard to sort of figure out, but it also advances science that much more quicker, because then we're looking at the moments where things are breaking apart and this one particular idea doesn't hold. So when we get to the point where, we've tried to falsify things, we've tried to falsify a theory time and time again, and it's been tried to be falsified under extraordinary number of conditions. We have tried to falsify everything that we possibly can, and it's been done under multiple contexts. Many different researchers have done this under all sorts of different contexts. Researchers from different countries, researchers under all sorts of, just as many things as can, as many times as we can, and if it holds for a very, very long time, if it holds for years and years and years, and people can never find a flaw in this particular theory, sometimes, and it's not often, sometimes they'll call it a law, just because it's been tested so many times. But we typically, science actually doesn't work that way anymore, where we there's laws. It doesn't hold as much, that sort of a term that is not used as much with sort of current science. It's because we're always skeptical of what's going on. So it has to be really, really, really rigorous before somebody is going to stand up and say, maybe we should call this a law. And it just doesn't happen that much. So that's science. That's the difference between a theory and a hypothesis. You can see how that sort of makes sense once you start doing it. And it's not different from how we understand the real world. We all have mindsets. We all have the way that the world actually works right now. We all have our own individual beliefs, or a group of beliefs of how that works. And then as human beings, we go about and actually going and testing these particular mindsets or these particular things by going and doing something. And then when something doesn't show, or we have this sort of belief in how the world works and it doesn't work the way that we should, some of us will try to revise those beliefs. Not always, but some of us will try to revise those beliefs and try something that's different. So that's it. That's the difference between theory and the hypothesis, and as well as the law, if you're curious about it. And you can see it's not as scary as what you think it is, and not as sophisticated as what you think it is. It's really just a lot of intuition in terms of how this all works. So Tessa, go do something nice for us. We do appreciate it. Leave some comments below. Love to hear what ended up happening, because I know you're gonna do it. All right, with that, give me a thumbs up. Do subscribe to the YouTube channel. Take care and have a wonderful day. Bye.